Thanks. Good afternoon, everyone. My name is David Allen. I run the NVMe SSD product line for Seagate. I also sit on the NVMe board of directors and have been working in the marketing group with the NVMe group as well. We set a lot of feature direction in that group, and then we deploy those features in our SSDs. I'm going to give you just a brief snapshot of what's happening kind of in the marketplace real quickly. You've got a lot of SATA transitioning to NVMe as those form factors start to get deployed that have been traditionally SATA. If you look at the PCIe SSD form factors themselves, the add-in cards were the basically the primary original form factor, with M.2 being picked up in 2016 in the hyperscale segment. So M.2's really got a big lift on that form factor as they deployed into the hyperscale folks. That rolled over into boot drives on standard servers as well. So M.2's primarily hyperscale, different configurations and carrier cards there, as well as some boot drives on the OEMs. Moving forward now, you're starting to see a lot of U.2 deployments. NVMe is really starting to, with the server deployments, starting to have a lot of serviceable hot plug access on those front panels that are now available to NVMe slots. So this is kind of what the transition's looking like. In the future, we have this new form factor, the EDS-FF. There are multiple form factors that have been encompassed within that. They're working on the connector definition as it is today. You'll see some pluggable type form factors that are high density, short M.2-ish, ruler type form factors, long and short. We'll talk about those as we get to the end. The Olympus form factor that Microsoft is working on, as well as some storage form factors. So we'd really like to see some consolidation in those pieces as we move forward, and we will. I don't really expect those to come out to like PCIe Gen 4. That's when you'll start to see some of those new form factors being deployed. There we go. This is the NVMe roadmap. I just want to talk about this one side right here. New features are being deployed in different versions of the roadmap. This is the base swim lane of this roadmap. We have NVMe over Fabric and then NVMe MI. In 1.3 on the base spec, the key features that were deployed there were Sanitize and Streams, some of the pieces that enhance security with respect to sanitizing, where you really go wipe the data off the drives. And then Streams, I'll talk in more detail about that. NVMe 1.4, IOD is, IO Determinism is one of the key features that's being worked on as we speak. And then there'll be some talks at the show as well on persistent memory region and controller memory buffer. Those really are key features here that are required for NVMe over Fabric. And then in NVMe management spec here, SES has been a long-standing SCSI command management command set that's being incorporated into NVMe. And then we're also deploying a spec around NVMe MI that allows for in-band communications across PCIe, so that you don't just have to use the standard SM bus for management aspects. Let's talk a little bit about some of these key features. In our products, we're deploying what's called QBoost, and it encompasses both IO Determinism and Streams into the feature set of our NVMe SSDs. If you look at IO Determinism, if you have a non-IOD drive, you basically have a lot of workloads hitting that drive, all at once. And any background tasks that are associated with that drive can impact one of those workloads. With IOD, you're basically taking that drive, carving it up into physical drives that allow the workloads to only hit a portion of the physical piece of that drive. What this does is, if any background operations were going on in this scenario, it could impact any of those workloads, and you could get quality of service interruptions. So your 5 nines, your 6 nines, those kinds of latencies can increase. With IOD, you're basically segmenting those workloads to one specific section. And if there's any background tasks going on in that section, you're not impacting the other workloads that are being hit here on the other portions of the drive. Again, it's a very physical type implementation with respect to that. The goal here is to reduce latencies overall in your implementation. We've seen in our demo, if you come over by the booth, please do, we're just right behind us over here. We've seen about a 7x reduction in latencies, especially on those outliers. And even on the maximum latencies, we've even seen about a 14x reduction with respect to some of these implementations. And as the hosts get more intelligent, there are actually commands that will be sent from the SSD back to the host that will let them know which of those segments of the drives are not really being used right now, so that they can extract that data with with hardly any latencies. Okay, let's talk about streams. A little bit different implementation. Workloads are coming into a drive, a non-stream type drive, and they get scattered across the drive here. Streams was really invented to reduce write amplification of the drive. And if you have a stream, what they do is the host will take these workloads and group those workloads according to a collection of data. It's not serial data, but it's like data that's very similar in nature. They bundle that into a stream. It is sent to the drive in these different segments. The drive handles these in a garbage collection unit, such that when you're doing garbage collection, you're only impacting this stream here, or the following stream that the data has been identified with. So it's a very good mechanism for handling like data. You can erase that entire stream. You don't impact the other streams, and your write amplification factors get much improved. If you look at our demo, we've seen a 2x to 4x improvement in write amplification on the drives themselves. So again, these two features that are incorporated in our QBoost technology are really some of those key pieces that are really helping lower the total cost of ownership of SSDs and provide optimum performance as we move forward. Very quickly, I wanted to talk a little bit about Olympus, OCP design here. The nice thing about this, it's a high density form factor. It's a long, slim form factor that utilizes M.2 devices. These are standard form factors that we provide. And there are 4 M.2s on each one of these devices. And it just provides a very cost-effective implementation with respect to this high-density form factor as we move forward. I think you'll see, Olympus, some of these new form factors really start to take advantage of in the PCIe Gen 4 timeframes. So I just wanted to give everyone kind of an overall idea of the new features that we're deploying in our products. And please visit us at the Seagate booth. It's just right behind us here in A14, and I'll be free to answer any Q&A that you have on those products. Thank you.